So this practice SAT problem presents us with a system of equations, and they say for each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system. So if you've solved systems graphically, you're looking for the intersection of the graphs. If you look at these answer options, I would expect most solutions to systems of equations to be numbers for x and numbers for y. And that is not the case with any of these answer options. So that kind of keys me in on the fact that something a little suspicious is going on with this system of equations. So what I did is I took both equations, the top one I've done this in blue and then the bottom one I've done this in red. I took these equations and I solved each of them for y. I got them into slope-intercept form. One equation has infinitely many standard forms, infinitely many point-slope forms, but one linear equation only has one slope-intercept form. And in this case, if you isolate y in both of these equations algebraically, what you end up with is you end up with the same equation. So if these lines actually graph the same line, they are intersecting everywhere on the line. Now, if you look at these options here, if my x is represented by the real number r, do either of these options for y in option C and D seem to match up with what we got here? The y value would be computed by taking negative 2/3 times the x, which would be r, and then adding 7/3. This one's really close to matching correctly, but it's missing the negative out here. This one has the negative, but it has that fraction inverted. It has the reciprocal of that fraction. So it seems like C and D, although they have some of the right components floating around within them, neither of them is really going to be the correct option. So then I looked at option B. What if the y value is specified by r? If the y value is specified by r, what calculation would I do with that r to determine my x? So I took either version of this equation in slope-intercept form, and I solved it for x. So I subtracted 7/3, I divided both sides by negative 2/3, and what that ended up giving me was a negative 3/2 times y plus 7/2. Negative 3/2 times our y, which is specified by r, plus 7/2. This is a pretty tricky question. Definitely some things happening in it that aren't quite the norm when you're solving a system of equations, but hopefully this has made a little bit of sense.